so our project is automating status of a wheelchair by electrooculography. I'm Abraham.
I'm Chau.
I'm Bob. Alright, so basically, why is this important at all, and why are we looking at this? We want to have people who are inhibited by their body, so they can't function normally. So basically, we're going to focus on disabled people who are affected by, but not limited to, paraplegia, stroke, multiple sclerosis, arthritis, cerebral palsy, and much, much more. And basically, we wanted to assist them in everyday functions and just be able to move around environments and say going up and down a ramp or going through a narrow doorway, all the while they can avoid collisions and just move more efficiently in that wheelchair on their own. So some background information on this. Electrooculography, I'm just going to call it EOG. And then it's a technique to measure the resting potential of the retina, which is a light-sensitive tissue lining the inner surface of the eye. And originally, it was used to record eye movements and ophthalmological diagnosis, which is basically just the physiology, anatomy, and disease of the eyes. But it's branched out a lot since then. And basically, how it works is the eye acts as a dipole, which the anterior, the front of the eye, is positive, and the posterior, the back of the eye, is negative. And the wheelchair, it monitors the bioelectrical signals and allows the system to let the user move the wheelchair using only their eye movements. And the EOG potential is a function of the position of the eye relative to the head. So you can see the image here. There's the electrodes on the left and the right side of the eye, which measures the horizontal movement, and then vertical position for the top and the bottom electrodes, and then a reference electrode. And then, okay, so basically in this diagram you see it's different. The electrical signal sent is different because of the position of the eye. So say you're looking straight ahead, its potential is different from when you're looking left or right, and then the wheelchair would register that. So the analog signal from oculographic measurements is translated into signal for control purposes of the wheelchair. And with this, we can increase communication and control between the wheelchair and the user.
Right, so the EOG is used in the wheelchair as follows. The electrodes are placed, and once again, it traces the eye movements. And these eye movements convert to electrical signals. And using components that we learned in class, it actually filters and amplifies the sound first because there's unwanted artifacts and unwanted activity, such as leftover remains from the, let's say, heart activity or brain activity, or even your eyelids kind of twitching out, whatever. So if you look, this is the unfiltered data. There's kind of aberrations in it, but once it's filtered, it kind of evens out, so you get a nice little reference level. And then it communicates to the wheelchair in the following way. Different eye movements are interpreted as different commands. If you look at the top right, there's a box with top, bottom, left, and right thresholds. For the top and bottom thresholds, if you pass the top threshold, it takes it as a command to speed up. If you pass the bottom threshold, to slow down. Left and right will control your angular speed based on where you're looking. So as you keep focused on a point, it will increase your speed until you line up with it, which will stop. There's also emergency commands, including reading blinking, as well as an override system. If you get the infrared and ultrasonic sensors that are placed into the wheelchair, so in case you fall asleep or something, it knows, oh, stay away from walls, and it'll be able to detect that. This is the software integration for the wheelchair. As you look on the screen, it will tell you where you're looking, how much signal you're getting in the horizontal and vertical, as well as the calibration menu, and to see the angle of your vision. And so overall, the wheelchair schematic looks like as follows. There's input devices, including voice, if you're able to talk, and then also, of course, your eye movements. And output, there's voices that come out as well as the screen. There's infrared and ultrasonic sensors to work in safety. And of course, there's the mechanical motor functions for your wheels and processing computer to take your eye electrical signals and converting to your commands.
All right, so here's the results of the experiment. That in the upper right-hand corner is the wheelchair. The blue line is the desired line for the path of the wheelchair, but the red line is the actual path. So as you can see from the results of both of the pictures, the wheelchair actually did pretty well and moved with the desired line. These weren't the only tests. There are other paths that we tested, and the results were similar. So the deviations were very small, meaning the experiment was pretty successful, and the EOG works pretty well with the wheelchair guiding. There's more uses than just the wheelchair. Someone has created a apparatus so that someone who's mute can use the EOG plus the software that he created to find letters on a computer and put them together for words, so overcome communication. Also, other people are using the same concept for a robotic arm for people who can't, they're paralyzed bottom up. They'll look at what they want to do, and the arm will do it using the same concept as the wheelchair. Even though it's really useful for helping disabled or medical uses, it's not only limited for those functions. The company has created a neural impulse actuator over there, and pretty much this is for people who like to play games. They wear the headband, and they have the software, and it's supposed to increase their gameplay, such as moving and just overall increase their overall performance. So they put on the headband, and the EOG records the movement of their eyes. And so, for example, if I was to look left, then my character would move left. There's future works. It's a good idea, but there's a lot of improvement that it could go through, such as design conveniency. As you can see in that picture, it's not convenient to put on the electrodes every time you want to talk. If you're mute, it's easier if you just wrote it down. So there's vast improvement for it. Also, to make it economically affordable, because these parts are expensive and not everyone can have access to it. So to make cheaper parts and easier would be really useful in the future. This website actually has a guy named Luis Cruz who created a apparatus for communication using EOG, and it's only like $150. So he's leading the charge, I guess, for affordable apparatuses using EOG. And here's our references.
Have a minute for questions. At some point, everybody should ask one question.
Okay, I have a question actually. So the wheelchair moves around with certain eye movements. Does that make it at any time inconvenient? Like if the person's doing something normal and doesn't want the wheelchair to move, will their normal eye movements move that chair? Yeah, like
there's a they link and stuff moving.
Oh,
Or there's a failsafe, or there's a back.
What if you do it by accident and then all of a sudden you stop moving?
Or then you just start moving again.
It traces kind of patterns, so it's translates to commands, but certain commands, not just once. Like let's say it's programmed a few things like 3 times in a row. And then nobody kind of just randomly goes, oh, my wheelchair stopped.
In a healthy person, when the eyes are normally healthy, the eyes undergoes normal random movements or pivots. Does the software sort of compensate for that?
That's why there's a threshold you have to pass before.
Right, but while it passes the threshold back and forth many times, are you using like a Schmidt trigger or some kind of diet status in here?
Yeah, so if it's passing the threshold, that's no longer healthy eye movement, right? Your eyes are spazzing out. So.
Oh no, I'm saying the hip is still, that's a normal.
Thresholds are pretty large. So
Oh.
it can be.
Last question.
Okay. The military has sort of like a gunship design where the autocam on the helicopter tracks where the gun is looking. Wouldn't that simply be an easier way to do this?
Actually, they thought of having it that way, but then they found out that you can kind of get confused when you start looking up and down because wheelchairs can't go fly.
Okay.